If you Google, what is a mineral, you're likely going to be given this answer, which I don't think depicts truly what a mineral is. You see, minerals are the building blocks of everything in geology. From the different types of rocks, pieces of sand, and even piles of dirt, it's all composed of minerals. Minerals follow a very specific set of rules. In order for something to be considered a mineral, they must follow these checkboxes. They have to be formed in nature, which means they can't be grown in a lab or in any other man-made setting. They can't be formed inside anything living, meaning kidney stones and any organic material is off the table. They have to be solid, or at least solid at room temperature. And finally, they must have a specific order to their atomic structure, which means that their compounds need to be arranged in an organized fashion. They can't consist of compounds bonded in random spots. Here's a few examples of minerals that you've probably heard of. Quartz, also known as silica, calcite, or for you chemistry nerds, calcium carbonate, and amethyst. A great example of how rocks and minerals can relate are found in this piece of granite. Granite is classified as a rock because it contains more than one type of mineral group. As you can see, there are traces of white quartz, biotite, which is that black color, and many other minerals. The chemical properties of a mineral are very important, and this will help scientists learn how to identify them. The way atoms arrange themselves within a mineral determines everything, from their color, shape, hardness, and even taste and odor. For example, this is the atomic structure of galena. Galena is a metal and is the main source of lead in the world. It's used for many applications, including batteries, radiation shielding, and metal production. The atomic structure of galena consists of sulfur, lead, and other molecules such as silver or silicon. These compounds come together to make this cubical shape, which we often find in nature with metals such as galena, pyrite, tungsten, and chromium. Here's a couple other examples of crystalline structures that can be found in nature, such as quartz, or a little more complicated one, such as garnet, which has several different formations that it can take. There are three main ways that minerals form: the cooling of magma, evaporating water, and metamorphic recrystallization. The cooling of magma creates deposits of compounds that have different densities in the molten rock around them. This process often creates minerals such as feldspar, olivine, and quartz. A popular example of how magma creates minerals in this case is geodes. Air pockets in magma cool down and trap gases that sublimate into crystalline structures. Geodes are often found with quartz or even fluorite structures. However, they can form into a variety of different minerals. Crystals such as halite and other salts form from the residue left behind from the evaporation of large amounts of water. This is often seen in dry deserts all across the world that were once oceans in prehistoric times. Finally, minerals can be reconstructed by the heat and pressure deep under the earth. This is done by recrystallizing compounds in other minerals and rearranging their atoms. As seen in the Naycan mines in Chihuahua, Mexico, extreme heat and pressure over thousands of years caused minerals that were dissolved in underground water to slowly crystallize into these massive selenite formations. Some of these crystals have grown up to 36 feet long and weigh nearly 50 tons. Minerals aren't just cool to look at. In fact, tons of them are actually part of our everyday lives. Take quartz for example. It's used in several electronics, like watches and phones. This is because its atoms vibrate at a super steady frequency, which simply means it's a really good insulator. Then there's salt. Yes, the same stuff you put on your dining table. Beyond cooking, salt is used in water treatment, road de-icing, and a bunch of other industrial processes. And even concrete comes from minerals. When you see concrete sidewalks or cinder blocks, those are made from crushed up limestone, different types of sand, and other minerals glued together. So there you go. Now, if you ever end up arguing about rocks and minerals, you can say you watched a video once and instantly win the argument.